Background job basics, local, WMI, and remoting jobs. We're going to get PowerShell working a little harder than normal. We're going to get it multitasking, doing multiple things simultaneously in the background while we continue to use the main interactive console for other stuff. It's all called background jobs, and as the name of this nugget implies, we'll be looking at 3 different types. We'll start with local jobs and the start job command, move on to remoting jobs and invoke command, and use get WMI object for some WMI background jobs. Along the way, I'll also be showing you some additional commands for job management and talking about some of the basic infrastructure of the job system within Windows PowerShell. Now, it's important to note that I'm only going to be talking about the 3 types of jobs that come with Windows PowerShell. Jobs, however, are an extension point in PowerShell. That means a module or PowerShell snap-in could potentially add a new type of job. I'm not going to be covering all the crazy things that someone could do with jobs. We're going to stick with the 3 job types that are native to Windows PowerShell. We'll start our jobs exploration on my Windows 7 computer using PowerShell version 2. Pretty much everything I'm going to show you actually works the same in PowerShell version 2, 3, and beyond from a syntax standpoint. In a second, we'll look at a couple of cool things that have been added in more recent versions than version 2, but the basics are right here in version 2. I'm actually going to start 3 different types of jobs using 3 different commands, and then we'll explore some of the different options for working with them and some of the different options that you can use when you launch a job for the first time. The first type is just the start job command, which accepts a script block. You can see that when I hit enter, I immediately get my command line back, even though you and I both know that that directory command is going to take a while to run. What I get back from start job is a job object. It gives me a unique ID number for the job. It also gives me a name that it made up. I could have used a parameter to specify a friendlier name for that. In fact, let's do that. We'll give it a name, super long directory fun, which I can't even spell correctly. There we go. And now I can run get job and see that both of those are still running. That state then is another important column. It tells me what the job is up to. You'll also notice the has more data. That means the job has already started returning output, and PowerShell is buffering that information in memory. In fact, I'll bet you as we open up Task Manager here and take a look at PowerShell, you'll notice I've got 3 different instances of PowerShell. Each job that I run is actually an instance of PowerShell. So if you're going to run a lot of jobs, then you're going to need a lot of resources to support them. You'll also notice that these things are sucking up memory like nobody's business because they're accumulating all of that directory listing information and storing it in memory. So that's something to keep in mind. If you're running jobs that are going to create a large amount of output, like these ones, you're going to need to have the memory on your computer to support that. In fact, I'm getting a little worried that I might not have enough. So I'm going to issue a stop job for ID 3 and just kill that job. Let's take a look at get job now. You'll see that that one is stopped. It still has more data. That means all of the data it had retrieved up to that point is still there. Let's go ahead and stop job ID number 1 as well. Oops, ID and get job. They're both stopped. Here's how we get some of that data out. Receive job from ID 1. Now I'm going to hit Control C so that doesn't just go forever, because my point is that's how you get the data out. And you'll notice now that job 1 does not has more data, meaning once you receive the data from a job, PowerShell no longer caches it in memory. It's gone. There's an option for that though. Receive job ID 3, keep. I'm also going to hit Control C here. So my real point is I want to run get job again and show you that job 3 still has a copy of that job data sitting in memory because I specified keep when I used receive job. Let's go ahead and get rid of both of those. Get job, remove job. Now if we swing back down to Task Manager, I should only have 1 copy of PowerShell running now, and it probably doesn't need all the memory that it says it's using, but it'll eventually free it up to the operating system when the .NET framework goes through and does its normal automatic garbage collection, or if the operating system asks for more memory. So those are local jobs. Start job is really intended for jobs that are going to run in the background entirely on the local computer and primarily access local resources. Although obviously you could have it go and access other resources if you wanted to. But here's another type of job. You remember that we've obviously done a lot with PowerShell remoting already, using invoke command. Well, let's come up with an invoke command here. Get event log, log name, security. Let's get the newest 100. Let's do that from domain, controller, and member. I'm not even sure if member's up and running. That'll certainly give us a good opportunity to see what this does with errors. I'm going to make this fully qualified names here. This is a very standard remoting command. It's the same that you've seen me run in any of the past nuggets that we've covered on remoting. The difference is I'm going to throw in an asJob parameter as well as a job name. Now, if I didn't use job name, it would make up a job name for me. This is just a way for me to have one that's a little bit friendlier to look at when I finally get the job object back. Now, if you've been paying attention, you'll notice the first job I started was job ID 1. The second one was job ID 3, and now this one is job ID 5. So you might start thinking, well, clearly job ID numbers are all odd numbered. Not entirely true. Here's a third type of job. Get WMI object. Class, let's just get something simple like Win32 logical disk. We'll target this at a couple of computers as well. And I really should use those fully qualified names on those so that DNS works a little quicker. Win7 is this machine, so it should be able to resolve that pretty quickly. Let's run this as a job as well. You'll notice now my job ID number is 8. So I've got theoretically 2 jobs running, number 5 and number 8. What's the deal here? Well, let's do a get job. Let's get job ID number 5 and use the expand property parameter of select object to expand the job's child jobs property. So you see, every job you start begins with a top-level parent job that actually coordinates the entire activity. You then always get one child job for each computer that's involved. If we do this same thing for job number 8, which is a parent job, we notice that it has 4 child jobs. And that's why the numbering of these initially seemed messed up. 1, 3, 5. It's because job 1 had a child, number 2. So the next one I started was job 3, which had a child 4. The next one was 5, which had children 6 and 7. The last job, the WMI one I started, was job 8, which has children 9, 10, 11, and 12. Now we've got a great example here in that you'll notice job 10, which was member, has failed, and that's because I have its firewall up, so it didn't allow that incoming WMI connection. Let's look at the top-level parent jobs again, and you'll notice that job 8 is failed, even though jobs 9, 11, and 12 all completed. So your parent job will usually offer you the worst case state of its children. That way, if even one of them fails, you'll notice that in this top-level output, and you'll know that you need to dig in and look at the child jobs and see who failed. Now that those jobs have completed, I have some options for retrieving them. I can receive job either from the parent, which will get me all of the children results, or I can just receive from one of the children. Now, if I do it for all of them, you'll notice that error flew by. Let me see if I can scroll back to that. This was the error from member. The RPC server is unavailable. Running get job now still shows me that there's some more data sitting in there. Get job ID 8, select, expand, child jobs. Oops, I didn't actually type the 8. That's important. That's showing me that everybody still has more data here, so it's still buffering it in memory, and I still have a failure here. But I'm done with that now. Get job ID 8, remove job. What's left? I've got ID 5, which was my event log getter. So let's just go ahead and receive that data as well. Receive job from ID 5. And you know what? Let's export it to a CSV file. We'll open that up in Notepad just to take a quick look at it, make sure it looks like a CSV file at least, and it does. Lots of information in here. In fact, if I scroll all the way to the beginning, you'll notice that because I ran this with remoting, it includes the PS computer name property. Now, how could I use that now that I have it in a CSV file? Well, simple. Import CSV, event log CSV. You know what? Let's format it as a table, and we'll group it by PS computer name. Now, this should have given me a separate table for each of the two computers. There's member, and at the top, there's DC, because I did the group by. So once you have the information out of a job, you really work with the results the same way that you would work as if you had run the command locally. You just receive the results, put them in the pipeline, export them, sort them, filter them, do whatever you want with them, really. Let's run get job, see where we're at. We still have job ID 5, but because I did not specify -keep when I received the data, well, now job 5 does not, has more data. Remove job ID 5. Might as well clean up after myself. Let's take a look at Task Manager. Here's my PowerShell task. It didn't look like my memory creeped up too much, so it's obviously at least starting the recovery process from the memory I used to buffer those results in memory. Now, you can obviously read a lot more about these commands in their help files, but there's a few things I want to point out right away. Let's do a get command on noun job. We looked at start job. You saw me use stop job, remove job, receive job, and get job. That just leaves us really with wait job. Wait job will accept one or more job IDs, and it will literally pause the shell until that job reaches the status you're after. And what that means is, for example, in a script, you could launch 3 or 4 jobs and then tell your script to wait until all of them complete. Now that allows your script to get multiple things happening at the same time because it's essentially spawning off new processes of Windows PowerShell to handle those tasks for you. When everything completes, your script would then continue. It's a great way of getting things running kind of in multi-processing mode, really. Now, one more thing I want to show you. Let's do an invoke command again. Let's pull that back because that was a lot of typing. Invoke command. I'm going to put a longer command in here this time. And I should give it a better name since it's obviously not event log getter anymore. Now, while that's running against those two computers, I want to take a look at Task Manager again. And you'll see here that I've just got the one copy of PowerShell running this time, but its memory is amping up. Now, that's because my local copy of PowerShell isn't actually running any commands. It's sent the commands off to remote computers. Those remote computers are running copies of Windows PowerShell to execute that directory command. My local computer just has to keep track of the one copy of PowerShell, but as those results come over from the remote computers, you can see that I'm incurring a memory load. Let's go ahead and stop job, ID 13. Now, stopping the job is not exactly like killing a process. Sometimes the job will continue running for a little bit until PowerShell gets to a point where it can stop. And here you'll notice that it did so. Let's remove job ID 13. And I'm just curious to take a look at Task Manager and see if it's still using quite a bit of memory, but that number will come down again once I kind of get to the normal automatic garbage collection cycle with the .NET framework. Let's take a look at some other options, particularly on invoke command. And when you use invoke command with a job, by default, it will still only talk to 32 computers simultaneously. It's exactly the same as if you used it interactively, meaning not as a job. You can change that by using the throttle limit. That really, again, only incurs an impact on your computer. Talking to more computers makes it harder for your computer, meaning you need more processor and mainly more memory to do it. The remote computers, no matter how many of them you're talking to simultaneously, don't suffer any additional impact load. So if you need to talk to 1,000 computers simultaneously, tell the boss you need a quad-core 64-bit computer with about 64 gigs of RAM, even if that's not true. It'd be nice to have one, I think. So those are the job basics. That's the basic infrastructure, the basic architecture that occurs, and the different ways you can use those. Remember, you got 3 choices for starting jobs here. Start job, mainly for local stuff. If we look at the start job help file, you'll notice that it doesn't let you specify a remote computer. So it's intended to run everything locally. You've also got invoke command, which uses PowerShell remoting to send commands to remote computers. And you've got get WMI object, which can also kick off jobs for you. So again, all of that is built into PowerShell version 2 and later. And here in PowerShell version 3 on my Windows 8 computer, everything's virtually the same. Just a couple of enhancements I want to point out. Let's do that invoke command style job again. Invoke command. Let's give it the event log trick again. We'll get the newest 100, so this doesn't run forever. And we'll do a few different computers. member.lab.pri, dc.lab.pri, client.lab.pri. And we'll run that, of course, as a job, because that's the whole point of this. Let's give it a job name too, event logs. There's our job object. Now, you'll remember that one way of seeing the child jobs of that is to do a get job of the parent, pipe it to select, and use expand property to look at the child jobs. PowerShell version 3 offers a little bit of a shortcut. You just have to run get job, give it the ID, and ask it to include the child jobs. You'll notice that this gives me the top level parent, which is number 2, as well as the individuals, 3, 4, and 5. So I kind of get a combined thing there. Another trick you can do is to ask for child jobs that are in a specific state, such as completed. And that's going to return all of the child jobs that are in that state as well as the parent job. Now from there, really working with these things is just the same. Receive job ID 3, keep, and only show me the first 10. Notice what I did there. I actually asked this to receive, what did I originally ask for? 100? Yeah, so each of these sets of results should be 100 or less. So I asked for job 3, which will potentially have 100 entries. I received them, put them in the pipeline, and then just grabbed the first 10 of those. Because I specified keep, they should all still be in there. If I ask for that job list again, you'll see that job 3 still has more data. And if I try to grab them all, but I don't select the first 10, you'll see that, well, roughly the first 100 are in there. So it's really great, easy to work with, very simple. And again, PowerShell version 3 and later supports all the same functionality, just a couple of little enhancements on the parameter side to make a couple of different tasks easier. If we run a get command noun job, you'll notice that we also have a new suspend job option and a resume job option. Certain job types will allow you to pause the job, and then you can come back and resume it later. Otherwise, get, receive, remove, start, stop, and wait all work the same as they did in version 2. So there you have it, the commands to start local jobs. That was start job. Remoting-based job used good old invoke command. And of course, WMI jobs using get WMI object. I also covered all the different job commands, starting them, stopping, waiting, and so on, and covered some of the basic infrastructure for the job system. Keep in mind, these are just the native types of jobs in Windows PowerShell, the things that come with PowerShell version 2 and later. Jobs are, as I said at the beginning of this nugget, an extension point, meaning as you add things into Windows PowerShell, one of the things you could be adding are new types of jobs. I hope this has been informative for you, and I'd like to thank you for viewing.